And the last topic for 8.3 is a telescoping series. Telescopes collapse upon themselves, right, when you fold them in. So this is a telescoping series, if you will, because the terms collapse onto one another into a simpler form. So that collapses into a simpler form, and that's where really it gets its name. And again, we're going to see shortly in 8.4 that it's often really difficult to find a formula for partial sums. And then, of course, you have to evaluate it at its limit to get the solution. Well, you know, there's only a couple of series that behave like that. And the geometric series is the one I really want you to focus on, but I want you to know that this telescoping series is out there. Okay, you know, I think what I'll do is just go through the example in the text, probably the best thing, and then we'll do one problem. So for a telescoping series, right, we're after that explicit formula. So here's the series that you generally see. It's in this format. So like anything with infinite series, start writing out the terms. And you see a pattern emerge. Right? Pattern recognition is a really key component to solving these series. And you're going to have to use that even more at the end of Chapter 8 and also into Chapter 9. So, you know, and some of you might have some difficulty with that, and that's okay. It's just something that you need to build. All right, and then others see it right away and it clicks. Okay, I don't know which one you are, but you know what? You just keep at it, and it'll click. Okay, so let's do some combining of like terms, right? You see a negative, let me grab a yellow. You see a negative 1 over 3 squared and a positive, right? We see a negative 1 over 3 cubed and a positive. So let's collect the terms. We end up with a 1/3 plus, I'm going to collect the positive and negative terms because they're going to collapse upon one another or go to 0. And we're going to be left with a formula, just like we were left with the geometric series when I showed you algebraically how to derive the geometric series. So it's very similar. These things are going to collapse upon themselves. And I want to look at this last term, or this next to the last term, and recognize that you've got something left over just like you did at the geometric on the tail. And that's a minus 1 over 3n plus 1. So, grab another color back. So what you notice is that these terms all cancel out, and what you're left with is a formula, 1/3 minus 1 over 3n plus 1 for this particular telescoping series. So now I can take the limit, because that's an explicit formula, right? The sum actually equaled this, okay, in the partial sum. So I need to take the limit of that as n goes to infinity. This term goes to 0, and you're left with 1/3. And that's your answer for this series. It converges to 1/3, and it's of the variety called a telescoping series. So there's a similar problem in your text, and I think I may have given you one in MML, maybe not, I can't remember. Let's go through it just in case I did give it to you. This is textbook number 47, and hopefully I gave you an example. If I gave you one, it's going to be just one, all right, because I want you to focus your attentions on the geometric series. I want you to know that hard and cold. So we're going to look at a finite sum like we did with the geometric. And I'm going to let this go to n because it's finite, okay? And then we'll extend things. Okay. So, again, we're going to write out the first few terms of this finite telescoping series now. Well, we don't know it's telescoping yet, I guess, until we work it out, but you know where we're heading. And you start to see the same sort of thing happen here that you saw in the example from your text, example 3. So collecting the terms, I can see that the positives and the negatives for the middle part of the series is going to cancel out. And we're going to be left with a leading term and a trailing term. So this boils down to 1/2 minus 1 over n plus 2. Now, you can take the limit as n approaches infinity of that explicit formula, and you find out that that goes to 0, and you're left with 1/2. So the telescoping series converges to 1/2. So that's it for chapter 8.3, and again, the tail end of it was really just a refinement of what we spent the bulk of class on Friday. So you can finish up your 8.3 homework, and then we'll be moving on to 8.4 on Monday.